Okay, welcome to this video where we're looking at the AQA Foundation Paper 2 for all of the topics that have come up on the Advanced Information list. Obviously, these are the topics that we're going to have a look at, so we're going to be going through a particular question on each of these. Now, obviously, when it comes to this, I am only going over one version of a question, so you do need to do your own revision, have a looking through your revision guides and everything else just to make sure that you're absolutely fine with all of these, particularly on the topics that you're not so sure on that I go over. Now I'm going to show you places where you can do that within the channel too, but obviously just make sure that you are doing some of your own revision as well and not using this as your only source of revision towards this exam. So let's have a look at where you can find some additional stuff within the channel. Okay, so when you're on the video, you can click into the description and you can go down and you can find all of the different papers that I've gone over for your exam board. If you carry on down into the description, you'll see down there that I've timestamped every topic within the video and put the full lesson link next to that. So as you're going through this, obviously you can skip and move between topics that you need to have a look at. If you pause the video, you'll see on the bottom left that you can click onto the chapters too, and you'll be able to click onto that and you can see all of the chapters pop down the video there and select the one that you're looking for. As well as that, at the top of the description, you've got links to the checklist that I just showed you, and also a link to the practice booklet so that you can print these off, you can practice them in your own time, or you can have a go after you've done the video or even before the video if that's what you'd prefer. So there we go, that is how you will go through this. That's how hopefully I can help you out with your revision there moving forward, but we've got a lot to get through, so let's get started. Okay, so when looking at order of operations, we can have certain different types of questions, and this one here we've got two parts. So here it says work out 4 plus 7 times 5. Now if we were to follow our order of operations, we would do the multiplication before the addition. So we want to bucket off these two and make sure we do the 7 times 5 first. So actually this calculation will say 4 plus, and then 7 times 5 is 35. So we've got to do 4 plus 35, which would give us a final answer of 39. Now in this part B where we're putting brackets in, normally that just means that we're going to have to put the brackets round the pieces that we wouldn't normally do first. So in this calculation, without any brackets, we would normally do the division first, and that would give us 15 add 2, and that would give us an answer of 17. And it wants us to put the brackets in here so that we get an answer of 5. So our only option is to put the brackets around the 15 plus 10. But we'll put the brackets in, we'll make sure that that works, and then we'll check our answer. So 15 plus 10 would be 25, and because the brackets are there, we would then divide the answer by 5, and 25 divided by 5 does equal 5. So that works, and our brackets would go around the 15 plus 10. Now when we're working out a fraction of an amount, we just need to have a look at that denominator. If something is being split into thirds, it means it's going to be split into 3 different parts. And if we were to draw this, and I'm only going to do this for this first example, but if we were to draw a little example with a little bar, if we were to split this bar into 3 portions, there we go, and I've not drawn it perfectly, but they should be equal parts, then that would be splitting something into thirds. So if we were going to figure out what number was going to go into this bar, bearing in mind we're splitting 48 into thirds, then in order to do that I would divide by 3. So to start with, I would do 48 divided by 3, and I just need to work out what that is. So if you need to, you can obviously do some division to the side. So I would go for bus stop division if you didn't know what this was off the top of your head, and we'll do 3's into 48. 3 goes into 4 once with a remainder of 1, and it goes into 18 6 times. So 16 would be each of our 3 parts. So if we put the 16 into each of our bars, that would be splitting it into 3. Now this question only wants to know what 2/3 are. So out of those 3 parts, we're only actually looking at 2 of them. So I would take my 16 there, find the total of the 2, or in other words, I would do 16 times 2. So in terms of just working out the numbers, we've got 48 divided by 3, which is 16, and that is equal to 1/3. So 1/3 would be 48 divided by 3. And then for our 2/3, which is what we are looking for, we'd take that 16, multiply it by the two parts we're looking at, and we'd get an answer of 32. And again, we could label that on the diagram just there as 32. So thinking about what we've done here, all we've actually done is looked at the denominator, and we've established that it's going to be split into three parts. So to do that, we've divided by 3, just here, divide by 3. And then because we want 2 of those, again, just looking at the numerator there, we've multiplied our answer by 2, and we've got a final answer of 32. Now, when we're looking at this sort of question here, one thing we need to remember, no matter which type of calculation we're doing, adding, subtracting, dividing or multiplying, if we have mixed numbers involved, we need to make them top heavy first. Now, when it comes to adding and subtracting, there is a little bit of a different approach that you can take that some of you may use, but I'm going to use the same method for all of these types of questions, and that is making any mixed numbers top heavy fractions first, or improper fractions first. So the process for doing that is obviously taking our fraction here, 3 4/5, we want to turn that into an amount of fifths. So to do that, we want to figure out how many fifths are in 3. So we can do 3 times 5, which is 15. Add the extra 4/5 there, and that makes 19 fifths. So 3 4/5, 3 times 5 is 15. Add the 4 that we've got there as well is 19 fifths. Okay, so it's the big number times the bottom to make 15, add the top number on the fraction there, 19, so we've got 19 fifths. And we're going to add that to the 3/7. Now when it comes to adding and subtracting, we need to have a common denominator. So we need that number on the bottom to be exactly the same. Now that means that we can multiply both fractions here, as long as we do whatever we do to the bottom, we also do to the top. We can make equivalent fractions with a common denominator. So thinking about 5 and 7, the lowest common multiple of those is 35. So in order to get them to be 35, the left fraction there, I can times the top and bottom by 7. And the right fraction we can times the top and bottom by 5, and that would give us 35 on the bottom of both. So we've still got to work out 19 times 7 there, and obviously take your time doing so, but 19 times 7 is 133, and at the moment that is going to be over now 35. Okay, so you get some quite big numbers here, but obviously don't be afraid just to the side to do some multiplication there. I did 7 times 10, and 7 times 9, and added them both together, okay, but you can show you working out to the side. On the right fraction there, we're going to times them both by 5, so 3 becomes 15, and 7 becomes 35. And now we're in a position where we can add these both together. So we can just add together the numerators, 133 plus 15, which gives us 148, and that is over 35, remembering that you don't add together the denominators. There we go, we've got 148 35ths. Now obviously it says here to give your answer as a mixed number in its simplest form. So it's up to you whether you try and simplify this or whether you so obviously turn it into a mixed number first, but we need to turn it back into a mixed number. So to do that I need to know how many times does 35 go into 148. That's not the nicest, so I'm just going to write down a few of the 35 times table. So 35, add another 35 is 70, add another 35 is 105, add another 35 is 140, and then it's not going to go beyond 140 there, because obviously our number there is only 148. So to go from here, we know that 35 goes in 4 times, so that's going to be a big 4. And what's left over from 140 to 148 is an additional 8 35ths. There we go, so 4 and 8 35ths left over. Okay, so just these two for converting a fraction. Now the first one here is quite a nice one, and you might already know what that is as a percentage, and that's fine, but we're going to have a look at the method for going about it. So when we have 1 over 4 and we want to write it as a percentage, not forgetting that that word percent means per 100, we want that denominator to be out of 100. Once it's out of 100, we can see what it is out of 100, and then we can write that percentage. So first of all, we need to think to ourselves, what do we multiply 4 by to actually get to that 100 on the bottom? And hopefully you can spot that that number is 25. Of course, if you're not sure, you could do 100 divided by 4 and some working out to the side to figure it out. But remembering whatever we do to the bottom, we have to do to the top. So 1 times 25 on the top gives us 25. Now it is a fraction over 100. Per 100, it's 25 per 100. So that will equal 25%. And there we go, we've got our percentage. So our process for this is to turn our fraction out of 100 and then basically just reading the numerator. For our next question, it does say to write it as a decimal. So to write it as a decimal, we'll first turn it into a percentage. and then again once it's a percentage, we can just hop the decimal before it and divide by 100 to get our decimal. So for 3/5, again we just need to spot what are we going to multiply the denominator by to make it out of 100. And that number that we need to multiply by for 5 is 20. Again, you could work that out, but if we multiply the top by 20 as well, 3 times 20 is equal to 60. Now that's 60 per 100, so that is equal to 60%, but of course we want to write that as a decimal, so if we hop our decimal in 2 jumps by dividing by 100, then that is going to give us a decimal which is 0.60. Of course you don't need to put the 0 at the end, so you can just write that as 0.6, but of course it wouldn't be wrong to write it as 0.60, but our final answer for this one is 0.6. Okay, so when writing decimals in order of size, we want all the decimals to have the same amount of decimal places. So if we look, our largest amount of decimal places is 3, and that's in this one and this one. So the 0.4 I would normally write as 0.400, and I'd also write the 0.35 as 0.350. Then we just ignore the 0 point and we'll just read the numbers after it. So we have 354, 400, 350 and 345. So the smallest number is going to be the 0.345, so we'd write that down. The next smallest is going to be the 350, which is the 0.35, so that would go next. Then we have 354, which is the 0.354, and then to finish it off we've got the 0.400, which is 0.4. And notice how I also wrote the original decimals back in and got rid of those additional zeros that I put. Okay, so in this question we've got a list of numbers. We're going to write down a prime number, and we're also going to write down a cube number. So for the prime numbers, we've got a few different options here. Well, 2. The first and only even prime number is 2. So for the prime numbers, we could write down 2, and we could also write down 5. Remembering that prime numbers are numbers that can only be divided by themselves and 1, and therefore they only have exactly 2 factors, which is the reason why 1 is not a prime number. So for this answer here, we could say 2, or we could say 5, but it only says to write down a prime number, so we'd only write down one of those. For the next one, it says to write down a cube number. So a cube number is found when you times a number by itself for 3 times. So for example, we could do 1 times 1 times 1, and the first cube number is 1. So therefore we could have 1 as a cube number. To recognise the rest, you'd kind of just have to do the calculation unless you already recognise them. But there is one more on here, and that is 3 times 3 times 3, which is 27. So 27 is also a cube number, and we have that in our list as well. So that's how you work out a cube number, and if we write one of these down, we would write down either 1 or 27, and again we'd just pick one of those and write them down as our cube number. Okay, so when looking at rounding to a certain amount of decimal places, this first one here says to round to 2 decimal places, so we would put a rounding line after that second decimal place. So it's either going to be 3.04 or it's going to round up to 3.05. In this case, there's a 5 after the line, so that's going to round up and it's going to be 3.05. And that would be our answer. Remember that when you're doing your rounding, it's either going to stay as it is or it's going to round that very last number up. Now this second one here says to round to 3 decimal places. This is quite a unique one. If we stick our line after the 3rd decimal place, you can see that there's a 6 after the line, so it is going to round it up. But we have 859 there, so because there's a 9 before the line, that's going to make it round up to 0.860. And then we could write that out like that, 0.860, that rounds the 59 up to 60, and because it said 3 decimal places, in this particular example, we'd actually leave the 0 in there, because that would actually keep it to 3 decimal places, even though the answer's 0.86 is exactly the same. If it asks us to write it to 3 decimal places, we'd keep that 3rd decimal, even if it's a 0. Okay, so when looking at inequality notation, we could just have to put some inequality symbols within these brackets or in these squares here, just to make sure that we are saying whether something is greater than, less than, or in this case we've also got equal to. So for this first one, we've got 13 and 25. Well, 13 is less than 25, so we would say less than in our box. For the next one, we've actually got to work this out. So 4 plus 9 is 13, and 102 take away 89 is also 13. So those two are equal to one another. For the next one, we've got 4 squared, which is 4 times 4, which is 16. And on the right there, we've got 4 times 2, which is 8. 16 is greater than 8, so we would say 16 is greater than 8, putting in our inequality symbol. And for the last one here, we've got -5 and -3. -5 is less than -3, so we would say less than -3. And there we go, that's using some inequality notation. Okay, so this question says on Monday, Alex earned £120 and she worked for 8 hours. Work out Alex's hourly rate of pay. Well, if she worked for 8 hours and earned £120, if we do 120 and divide that by the 8 hours, that's going to tell us how much she earned for every 1 hour. And that comes out as £15. So Alex's hourly rate of pay is £15. For the next part of the question here, it says on Thursday, Alex earned £120 and on Friday she earned £100. Alex earned the same amount of money on Monday, Tuesday and Wednesday. She earned a total of £550 for these 5 days. How much did Alex earn on Monday? Well, she earned the same amount of money on Monday, Tuesday and Wednesday. So let's work out how much she earned in total over those 3 days. So on Thursday and Friday, combined, she earned £220. Okay, £120 plus 100. Now, if we take that away from the total amount that she earned, which was £550, we'll know the total that she earned on Monday, Tuesday and Wednesday. So 550 take away 220, and that leaves us with £330. Now, because she earned the same on Monday, Tuesday and Wednesday, we can divide that by 3, which would perfectly split it into those 3 days, and you'll see that comes out as £110, and there we go. That would be our final answer. So she earned £15 per hour, and on Monday, Tuesday and Wednesday she earned £110, so on Monday it was 110. And he only has caramel, orange, coconut and strawberry flavoured chocolates. 2/7 of the chocolates are caramel, 35% of the chocolates are orange, and the ratio of the number of coconut to the number of strawberry is 4:5, and it wants us to work out the number of coconut chocolates that James has. So let's have a look. We've got 2/7 that are caramel, and we've got the next bit of information there that tells us that 35% are orange. And then it goes on to tell us that coconut to strawberry is 4:5. So if we start with the first piece of information here, and that's that 2/7 are caramel. So to break this down, we'll start working out one of those pieces of information. So to work out 2/7 of a number, obviously you need to know how to work out a fraction of an amount here. We're first going to work out 1/7. And to get 1/7, we're going to divide 420 by 7. So obviously if you have a calculator, this sort of question is relatively simple in terms of the calculations, but if you don't, you're just going to have to do a little bit of bus stop method to the side and working out 7 into 420. So 7 goes into 42 6 times, and then 7 doesn't go into 0 obviously, so we have 60 there. So 1/7 would be 60 chocolates. And obviously always leave your working out to the side. I'm going to get rid of that because we need the space, but obviously always leave your working out. Now we want 2/7, so we'll double that. So 2/7 would be 120. And then we've got our first piece of information. We've got there are 120 caramel chocolates. Now we can move on to the chocolates that are orange. So again, if we get rid of this and we'll just focus on the working out, in fact we'll just leave that there for the moment, we'll go with working out the 35% first. So to get 35%, again, if we'll assume that we don't have a calculator for this, we'll work out 10% and use our non-calculator method. So 10% is going to be 42, and 5%, which is half of that, is going to be 21. So in order to get 35%, we're going to want 3 of the 42s, that takes up to 30%, and then we'll add the 21. So completely up to you how you do that. You can either multiply that by 3 and add 21, or just to the side, again, always showing you working out, we could just add 3 of them together and then add the 21 and add that all up. We get 7 and 4, 8, 12, 14, so we get 147. And then let's add that up here next to our information, and that is 147 orange chocolates. Now we've got one last piece of information, and we're going to get rid of all of this and just focus on that for now. So this last piece of information here tells us that the number of coconut to the number of strawberry is in the ratio 4:5. And that is going to be for the remaining chocolates after we get rid of the caramel and the orange. Okay, so we need to actually work out how many are left just for those. So if we add together the 120 and the 147, that adds up to a total of 267. Now we need to take that away from the total, and we know that the total was 420. So 420, and we'll take away 267, and again, without a calculator, we're going to have to do a bit of work here. 7 from 10 is 3. We're going to have to carry again. 6 from 11 is 5, and 2 from 3 is 1. So that leaves us with 153 chocolates that are going to be coconut or strawberry. So we're going to write this as a ratio. So coconut to strawberry, and that is 4 to 5. I don't always dislike that when there's an S and a 5 next to each other. They look so similar. So we've got 153 that we're going to share in that ratio. So 4 and 5 gives us 9 parts in total. And again, this is sharing in a ratio. So again, if you need any reminders on how to share in a ratio, I'll put the link for this video in the description, so you can go have a look at sharing in a ratio if you need to. But let's share this 153. So we've got 153 that we need to divide by 9. And again, if we're not doing this with a calculator, we'll divide that by 9 and see what we get. So 9 goes into 15 once with a remainder of 6. And then 9 goes into 63 7 times. So that leaves us with 17. So for this, 1 part is equal to 17. So with our ratio, in order to turn these into the actual amount of sweets, we need to multiply them both by 17. So again, we can do 4 times 17, and again, you can just multiply that to the side or add them up using column addition, but that is going to be equal 68. And if you do 5 times 17, that's going to equal 85. So there we go, that is all of our amounts there. If we apply that back to the question, underneath coconut there, we've got 68, and underneath strawberry, we have 85. Now the question here did only say work out the number of coconut chocolates that James has, so for our final answer we would say 68, as that was the amount of coconut that we had after we worked out that ratio. So there we go, there was a lot going on in that question. You had working out a fraction of an amount, a percentage of an amount, finding out what was left, and then sharing that in a ratio. Okay, so this question says increase 250 by 35%. So if we're increasing by 35%, then obviously we're going to start with a 1-point number. So we're going to have 1 point, and then for 35%, that would just be 1.35. And that would increase for us by 35%. The 1 represents the 100%, the extra 0.35 represents the additional 35%, so that increases it by 35% for us. So into our calculators, we just need to type in 250 multiplied by 1.35, and if we type that in, that comes out as 337.5, and that right there is our final answer. There we go. Again, just thinking about the logic here, when you multiply something by 1, it doesn't actually change, it just sticks as it is. So adding the extra 0.35 there is just adding on that additional 35% on top of the original number. So this method works very, very nicely. It's very, very quick, but you just need to be happy to convert back into the decimal there. And if you want to think about the logic behind it, 35% as a decimal is 0.35. Okay, but obviously we're changing it to 1.35 to incorporate the fact that we are going to increase it. Okay, so looking at a single digit percentage. Now we're going to decrease here by 4%. So if we want to know what percentage is left over, well, if we take away 4% from our original 100%, we would be left with 96%. So if we're going to decrease something by 4%, we actually are working out 96% of that number. And 96% as a decimal can be written as 0.96. So that is our multiplier that we're going to multiply by. So nice and easy, we get 240 on your calculator, multiply it by 0.96, and if we type that in, 240 times 0.96, the answer comes out as 230.4. And there we go, and that's our final answer. So to work out a percentage decrease, we figure out what percentage will be left over once that has been taken away, and then multiply by that decimal version, which we call a multiplier. Okay, so writing a ratio in the form n to 1. Now this one does have decimals. We've got 4.5 on the left and we have 2.25 on the right. Now no matter what the numbers are, if we want to get it to be 1 on the right hand side, then whatever is on the right hand side here is what we need to divide both sides of the ratio by. So in this one, it is a decimal, 2.25, so we need to divide the right-hand side by 2.25. And when simplifying a ratio, we do the same to the left, so we would also divide the left-hand side by 2.25, and we can just type that into our calculator. So 4.5 divided by 2.25 is equal to 2. So our ratio is 2 to 1, and that value of n is 2. So just think about that when you're writing a ratio as n to 1. No matter what is in that 1 position, that's what you're going to divide by. Okay, so this question says, here is a scale drawing of the plan of a room. Mr. Ahmed wants to put bookshelves along the complete length of the wall labelled bookshelves, which we can see just at the top here. It then says there are two sizes of bookshelves. Large bookshelves are 150 centimetres wide and small bookshelves are 100 centimetres wide. Work out how many large bookshelves and how many small bookshelves Mr. Ahmed can put along the complete length of the wall. There's going to be different options for that as well, I'd imagine. It says here that the scale is 1 centimetre and it's drawn on a little centimetre grid, represents 50 centimetres. So every single one of these boxes is 50 centimetres. So if we were to put let's imagine the large bookshelves, they would take up 3 of those boxes, because if we divide each of those by 50, that is going to equal 3 centimetres. And for the small bookshelf, if we divide that by 50, that's going to equal 2 centimetres. So if we put a large bookshelf here, 3 across, and then another large bookshelf, that leaves us with 2 as a gap at the end there. It has to go all the way along. So another 2 would be a small bookshelf. So that would be 3 large bookshelves. I'll just put 3L and 1 small one. Okay, and 1 small. But obviously there could be a different way of doing that. So let's have a look at another way as well. And let's start off by putting the small bookshelves in. So that would be 2 for a small bookshelf, another small bookshelf, another small bookshelf, another one there, and then there's a gap there of 3, so we'd want to put a large bookshelf in there. So for this one, or we could have 1 large bookshelf, and that's 4 small bookshelves. So they're the different options that we could use. Either one of those would be fine, but there we go, that's one of our options. It says both the large bookshelves and the small bookshelves are 50 centimetres from front to back, so they are 50 centimetres deep. Draw these bookshelves on the scale drawing to show how they will fit. But obviously you can choose any of the options above there. I'm going to go with this one, so 3 large bookshelves and 1 small one. So if we were to draw them in, that would be 1 bookshelf, that would be another bookshelf, there's our third, and then we'd have a small bookshelf at the end, and that would be showing those on the scale drawing. Right, so when it comes to a best value question, we tend to have 2 different offers in front of us, and we have to compare and we have to see which is going to be our better value, and not in terms of which is the cheapest at the moment, but which is the cheapest in terms of a single packet or a single gram or a single milliliter or whatever the type of item is that we're looking at buying. So on this particular question here, we've got some toilet rolls, and we've got 9 toilet rolls costing £4.23 and a 4-pack of toilet rolls costing £1.96, and we want to look at which gives better value for money, and we need to show our working here. Now when it comes to this one, we're going to find the cost of 1. So when it comes to our first option, we've got a diagram over here. This is for 9, okay? So if we want to know the cost of 1, we just want to divide that cost by 9, okay? So in all of these questions here, when we're looking at best value, we get the cost of the item and we just divide it by the amount, okay? Now, we don't really want to have to remember a formula for this, so I tend to think of a nice easy example. I tend to think, you know, if I have 2 apples for £1, okay, so let's just imagine this. I always think of nice easy little ways of remembering it. 2 apples equal £1, okay, what do you actually do there to get the cost of 1 apple? Well, you divide by 2, okay? You get the cost on the top there, you divide it by 2, so it's £1 divided by 2, and obviously that would give us 50p. Okay, so I've just obviously made that example up off the top of my head. It's one that I always kind of try and remind students of. Just think about a nice easy example no matter what, okay? So it's always going to be the cost divided by the amount. So we need to show all our working out for this. So for the first option here, I'm going to write out £4.23. Oh, that's not a 2, there we go, £4.23. And we're going to divide that by 9. So £4.23 divided by 9 gives me an answer, and it comes out as 0.47 or 47p. Doing the same for the other option, we've got £1.96. There we go, and we're going to divide that by 4. So £1.96 divided by 4 gives us the answer 0.49 or 49p. Okay, so from there, obviously we can identify which is the better value. We obviously want the one that's going to be 47p per roll rather than the one that's 49p per roll. So we just need to make a conclusion in this. We would say the pack of 9 is better value. Okay, so I'm just going to write the pack of 9. There we go. Obviously back to by my working out there. Okay, so looking at writing a ratio as a percentage. It says here there are only red, yellow and orange buttons in a bag. And the number of red, yellow and orange buttons are in the ratio 7, 4, 9. Work out what percentage of the buttons in the jar are orange. Now, in order to work this out, there are two different ways. First of all, we want to know the total in this ratio. So we've got 7, 4 and 9. Now, the total there, if we add them all together, adds up to 20. So if they add up to 20, we could write all of these as a fraction. Now the orange is the third number in the ratio, so the 9. So as a fraction, that would be 9 out of 20. Now without a calculator, you'd have to turn that into a denominator over 100, which isn't particularly difficult. But if we have a calculator here, we can just do 9 divided by 20. And you'll see that that comes out as 0.45. And in order to turn that into a percentage, you'd multiply it by 100, although I'd hope that you know that that is going to be 45%. But if you're not sure on that, you can always times the decimal by 100 and it will turn it into a percentage for you. So for this one here, that comes out as 45%. Of course, you didn't actually have to use your calculator. You could have just times the top and bottom by 5, which would have given you 45 out of 100, which hopefully you then would know would be 45%. Okay, so here's another question looking at ratios with percentages. It says here, Carl puts tins into small boxes and large boxes. The small boxes have 6 tins and the large boxes has 20 tins. He puts a total of 3,000 tins into the boxes, and then it tells us the ratio of small to large and says that it's 2 to 3. It says Carl says that less than 30% of the boxes are filled with less than 30% of the boxes filled with tins are large boxes. Is he correct? Well, let's actually work out how many tins are in each of the boxes. So if he puts 3,000 tins in total into the boxes, and that gives us the ratio of 2 to 3, then we can work out how many tins went into the small boxes and how many tins went into the large boxes. So just sharing that in a ratio. So in that ratio, there's a total of 5 parts. So if we do 3,000 and divide by 5, we know that each part is worth 600. So we have small to large, that is 2 to 3. So if we times both of those by 600, we'll know how many are in each one. So 2 times 600 is 1,200, and 3 times 600 is 1,800. So there are 1,200 tins in small boxes and 1,800 tins in large boxes. Now we can actually work out how many boxes there are that he's filled, because we know that there are 6 tins in each of the small boxes and 20 tins in each of the large boxes. So for the small boxes, if we divide this by 6, because there are 6 tins in each of those small boxes, so 1,200 divided by 6 would give us 200 boxes. For the other one on the right, I'm not going to write this as a ratio because we're not really working out a ratio here, we're just working out how many boxes have been used. Or we could think of it as a ratio of the boxes. So for the next one, we've got 1,800. There are 20 tins in each of those boxes. So if we divide that by 20, and 1,800 divided by 20 would equal 90. So there are 90 large boxes. So it says Carl says that less than 30% of the boxes filled with tins are large boxes. So we'd need to work out what percentage those 90 tins are out of all of the boxes. Well, there are 200 small boxes and 90 large boxes. So that is 90 boxes out of a total of 290 boxes. So if we do 90, divide it by 290 like that as a fraction, we get 0.31. And there are some more decimals there. I'm going to keep that as 0.31 because if we were to turn that into a percentage, that would already be 31%. So if that's already 31%, and we already know that Carl's statement is incorrect because it says Carl says that less than 30% are filled in the large boxes. So we've just worked out, well, actually, no, it's 31%, and there is a little bit more after that, but actually we would say, no, Carl is not correct, okay, because it's over 30%. So we would make that statement, no, Carl is not correct. And there we go. So that wasn't the nicest of questions there, but another type of question that involved ratios and percentages. So this first one is 10 workers take 4 days to complete a job. How long will 8 workers take to complete the same job? Now logically we've got less workers, so it's going to take more time. What people are quite tempted to do here is to say, okay, well 10 workers, 4 days, divide it by 4, working out 1 day and then timesing it by 8, and that's completely wrong because that's going to give us a much lower number there than the 4 days. And logically, if we've got less workers, it's going to take more days, unless of course those workers are more highly skilled and they happen to take more obviously less days, but we're going to assume that it's the same type of workers here. We're going to talk about these assumptions as well in a sec. But having a look at this question here, we've got 10 workers take 4 days. Now if we imagine, and this is always the case, we've got to think, all right, well if 10 workers take 4 days, how long would 1 worker take? Okay, and 1 worker would take 10 times longer, we would assume, okay, than obviously having 10. Just like if we had 2 workers doing a job, it would take them twice as long if it was just the 1 person. Okay, we times it by 2. So here, if we've got 10 workers taking 4 days, it would take 10 times 4, 40 days for 1 worker. Okay, and that is how long we would expect 1 worker to take. Okay, 10 workers take 4 days, so times that by 4, 4 times as long would be 40 days. And that's the first piece of information that we really need to work out here, because that's how long in days it would take 1 worker to complete this job. Now it says here that we've got 8 workers, okay? So we've got more than 1 worker, we've got the 8 workers. And if we've got 8 workers, we would assume it would be 8 times faster. So if we want to work out 8 times faster than 40 days, we can divide that by 8, and 40 divided by 8 would give us a total amount of days there of 5, so we would have 5 days to complete the job. Okay, so it's inverse proportion. Obviously we have more than 4 days there, we've got 5 days, it's taken longer. Our answer makes sense, and we just need to think about the logic behind that there. Obviously multiplying it by 4, 4 times as long for 1 worker, but obviously for 8 work it would be 8 times faster, making that number, that 40 days there, shorter and down to 5. Okay, we are making some assumptions here. We are assuming that all the workers work at the same rate and they have the same skill. And obviously if this wasn't the case, our answer could be bigger, it could be smaller, but we don't know. Obviously more skilled workers, our answer could be smaller there, we could be less days, and less skilled workers, our answer could be bigger, it could actually be longer than 5 days. Okay, so let's read through this question. It says here that 5 boxes of cereal have a total weight of 1,750 grams. It then says that 4 boxes of cereal and 3 sachets of sugar have a total weight of 1,490 grams. Work out the total weight of 3 boxes of cereal and 2 sachets of sugar. So this question's different because we have 2 different variables. We have the cereal and we have the sugar. So we need to figure out one of them first, and let's have a think about which one we can work out straight away. Because that first line just says about one of the variables, it just says 5 boxes of cereal have a total weight of 1,750. So we can work out one of the boxes by dividing that by 5. So let's just have a think. We've got 5 boxes is equal to 1,750. So our first step to get the weight of one box would be to divide that by 5. So we will divide it by 5 and we'll do our working out to the side. So 1,750 divided by 5, well 5 goes into 17 3 times, remainder 2, goes into 25 5 times, and then 0 at the end. So the weight of one box is going to be 350. Of course this is in grams. And the final part of the question, which we don't have to work out straight away, but it wants us to ultimately work out the weight of 3 boxes. So straight away we could multiply this by 3, and again you could work this out at the end once you've got the singular weight for both, but we may as well just straight away times that. So 3 boxes, and that is going to be 3 times 350. 2 times 350 is 700, add another 350 is 1,050. Again, you could spend some time just adding 3 of them together using column addition or multiplying it by 3, but there we go, we have the weight for 3. So let's get rid of this working out and move on to our next piece of information. So the next part is obviously we have the sachets of sugar. So for this second line here, it says that 4 boxes of cereal and 3 sachets of sugar have a total weight of 1,490. Well, if we work out the weight of 4 boxes of cereal, as we know the weight of 1, then we could have a look at working out therefore what the weight of the 3 sachets of sugar are going to weigh. So if one box is equal to 350, 4 of those boxes is going to be 1,400 grams. And obviously it says in the question that the weight, including the 3 sachets of sugar, is 1,490 grams. So that is going to be adding another 90 grams. So those 3 sachets of sugar are equal to 90 grams. So we can write that down. So 3 sachets is equal to 90. Of course, we want to break that down and go back to 1 sachet. So we can divide that by 3. So if we divide that by 3, we're going to get that 1 sachet is equal to 30. There we go. And obviously the question here, and we'll swap colour again, wants us to work out the weight of 2 sachets of sugar. So we can straight away multiply that by 2. And if we multiply that by 2, we're going to get that 2 sachets is equal to 60. And that is the second part of our answer. Now, of course, this question here said work out the total weight of 3 boxes and 2 sachets. So we're going to want to finish this off by writing the total weight. And that is to take our 1,050 and our 60 and add them together. So for our final answer, we'd do 1,050 plus the 60, and that is equal to 1,110. And that is in grams, and that is our final answer. Okay, so 2x plus 9 equals 16. Now taking the same approach here, we'll take away the 9, so minus 9, and we get 2x equals, take away 9 from 16, leaves you with 7. Okay, so the first thing you might be noticing here is, oh well, hold on, 7 doesn't divide by 2. Well, it does, it's just not going to give us a whole number. So we'll take the same approach again, we'll divide by 2, because we've got 2 times x here, so divide by 2, and we get x equals 7 over 2, and that's fine just to leave that as a fraction. Now obviously when it does simplify down, I would advise you go for it. Okay, 2 goes into 7 3 times, so we have 3 and 1/2 left over, or you could write your answer as a decimal, you could write 3.5, but it's perfectly fine for you to just leave your answer as a fraction and then write it as a mixed number, or simplify it in any way that you think is appropriate for that type of question. Okay, so 2x minus 2 equals 7x plus 8. Now this time the smaller value of x is on the left hand side. That's fine though, we'll just get rid of 2x. Okay, on both sides, and we'll see what we've got. Now when we do this, you've got to be careful because this is negative 2, which is going to be left here. So that's going to be negative 2 on the left, and it equals 5x when we take away the 2 plus 8. Okay, so we've got the x's on the right hand side, so we want to get rid of this plus 8. So to get rid of a positive 8 there, we're going to subtract 8 and do that from both sides. Negative 2 take away 8 is negative 10. So negative 10 equals 5x. And then finish it off just like normal, we're going to divide by 5. So divide by 5. Negative 10 divided by 5 is negative 2. So negative 2 equals x. Okay, and it doesn't matter which way it's written around, we can just rewrite that if you want. X equals negative 2. And there's our final answer there. So we can have fractions, we can have negative numbers, we can have whole numbers, okay, but ultimately we just need to make sure we get the x's on one side, the numbers on the other, and then just make sure we solve it just like a normal equation there. Okay, so simplify this, 15 minus 4x minus 9 plus x. Let's have a look at what we get here. So the numbers I'm going to start with first, as is a number first, although you don't have to. So I've got 15 and a minus 9, and 15 take away 9 is 6, positive 6, so I'll just write 6. Okay, so that's what those two came down to make. Now I'm going to look at the x pieces here. We've got negative 4x, add x. Now if there's not a number in front of it, that's 1x, so we've got minus 4, add 1. Minus 4, add 1 is minus 3, so minus 3x is there, and as it is minus, I need to make sure I emphasize that it is negative, so negative 3x, and we get 6 minus 3x there as our final answer. Okay, so if you rewrite this, you can put little circles or little boxes around the pieces, but just make sure you have a look at what symbols are in front of them, if it's positive or negative, and make sure that they go alongside that piece. Okay, so expand and simplify this. Now we've got this minus 2 in the middle here, so we just need to be careful, but let's just treat it in exactly the same way. We'll times the first bracket by 3 to start with, so 3 times 2x gives us 6x, and 3 times negative 4 gives us negative 12. Now let's have a look at that second bracket. So we have a negative 2 at the start here, so we're just going to have to remember to times by negative 2. So negative 2 times x is negative 2x, and negative 2 times positive 5 gives us negative 10. Okay, so the symbol's not just getting copied there, it is getting affected by that -2 at the start, so be very, very careful with this -10 here when you're doing these. Right, so collecting it all together, we've got 6x, take away the 2x, and that leaves us with 4x's. And we've got -12 and -10 here, -12 take away 10 is -22. And there's that expanded and simplified. Okay, so expand and simplify this one. So we've got a negative in the second bracket. So I'm just going to rewrite this. We just need to make sure we're careful with that. So x plus 5 and x minus 2. Now following the same process, I'm going to do the x times the x. I always do those first, get that x squared piece at the start. So we get x squared. And then the x times the -2. So being careful this time because it is -2, so it's going to be -2x. Okay, just be very, very careful of the symbols. Then onto the 5, it's positive 5 times x, so positive 5x. And then positive 5 times -2, positive times a negative makes -10. And then again, we just got to simplify this. So tidying it up, just being careful here because we've got -2, add 5 in the middle. -2 add 5 is positive 3, so we end up with positive 3x in the middle. And again, keeping that -10 at the end, and that's there expanded. Okay, so this question says factorise fully, and that normally means because there's two factors that can come out. So let's have a look. We've got 12x squared and we've got 10x. Now straight away they've both got an x in and they've both got a number. So let's just look at the numbers to start with. So numbers that go into 12 and 10, our only option there is 2. So we can definitely take a 2 out. But there's an x in both as well, so we can also take an x out. Okay, we're just having a look at what goes into both. 2 goes into both those numbers and x goes into both the letter parts. So 2x on the outside, open the bracket. Now what do we multiply 2x by to get to 12x squared? Well, from 2 to 12 we have to times it by 6, and to make sure we get the x squared as well, we've also got to put an x in there. Again, just copy the sign, we finish with that piece. How do we get from 2x to 10x? Well, from 2 to 10 is 5. So times that by 5, but we don't want to put an x in with that piece because we don't want an x squared up here, just the 10x. So that's that one finished. There we go, 2x brackets 6x minus 5. Okay, so a different one. I've got a negative symbol in the middle, we've got -8x in the middle, and I've got plus 16 at the end. So same again, I'm just going to draw myself a blank double bracket and stick my x in the front of both of them. And then just think, okay, what numbers times to make 16? So I can have 1 and 16, I could have 2 and 8, and I could have 4 and 4. And then I just need to figure out which numbers are going to allow me to get this -8 in the middle. Now you might just be able to get to a point where you can actually spot this. I have got to be slightly careful in this one because it's a -8 and a positive 16. And thinking about the logic of numbers here, in order to multiply to get positive 16 at the end, this piece here, they're either going to both have to be positive or both have to be negative. But in order to get a -8 in the middle, it can't be the two positives, it's going to have to be the double negatives. So both my numbers here are going to be negative, and let's have a look why. So in order to get -8, I can't make that out of 1 and 16. I definitely can't make -8 out of 2 and 8, because one of them's already 8, so it's going to have to be 4 and 4. And the process of making -8, I could do -4, take away 4, so 2 negatives there, so -4, take away another -4, or take away another 4 would allow me to get -8 there. And again, you can always double check these, you can expand them. So if I expand it, I get x times x, which is x squared. I get x times -4, which is -4x. Same again on the bottom, -4x. And then -4 times -4, which gives you positive 16. And then again, just tidying up those middle pieces shows you why you get the -8 here, because we end up with x squared minus 8x plus 16 at the end. Okay, so you've always got that option there just to double check your answer. Okay, so looking at coordinates, it says write down the coordinates of point G. Now, point G is over here, so we just go reading the bottom, which is 4, and then whatever it aligns with going upwards, which is 3, so that would be 4, 3. Remember, with those coordinates, you read the x coordinate first going across, and then however high up it goes. On to the next one, we're looking at h. So the coordinate of h goes -4 across, and then we're going down for this one, and it goes down to -1. So that coordinate would be -4, -1. You should be very careful not to get those two mixed up and writing them the wrong way round. For part C, it says find the coordinates of the midpoint. So to find the midpoint, there's a couple of different ways that you could do that. You could get your ruler and a pencil, you could join that up nice and straight using a ruler and a pencil like that, and then find the middle. And you could do that in two different ways. You could either do it by eye and try and spot the middle, although you're going to have to be absolutely perfect when you do that, or we could think about it as a bit of a pattern. Now, if you look at the actual points, if we look at a distance going across, it's 8 across to get from H over to G. That's a movement of 8, and we'd have to go 4 up to get to G, going upwards. So to find the midpoint, if we just do half of that, so if we go 4 across and 2 up from H, that's going to land perfectly on the midpoint. So you've got to remember those numbers. We're going to go 4 across, which gets us to here, and then go 2 up, which would get us to just here. So our midpoint, and I'll do this in a different colour, our midpoint is going to be on that coordinate right there. So that coordinate, if we write it down, is the coordinate, and that's 0 across, so it's 0, and 1 up, so 0, 1, and that'll be our midpoint. You just always want to check as well, is it 4 across, 2 up to get to there? Yep, so it's definitely the middle. So there we go, that's how you go about finding a midpoint. You just look at that little pattern and then halve it to see where the middle is. Okay, so on the grid, draw the graph of y equals 3x minus 2. Okay, this time it says for the values of x from -1 to 3. And again, that's what we actually have on the graph there. We have from -1 over here, going across from 0, 1, 2, and finishing at 3. So we can use all these x values to draw our little graph. And again, I'm just going to draw a little table for this. But again, thinking about this equation and what it actually means, it has a y-intercept there at the end of -2. So we know it's going to cross through this coordinate here. And it has a gradient of 3, which in terms of just drawing a pattern, if I was to show you how I would actually draw this, if we go across 1 square, so that's 1 there, and then go up 3, again, just being careful of the scale there, that's where our next coordinate's going to be right there. Okay, but we'll see that when we actually draw the graph. But you can actually just do this following the pattern. It's not going to help with the progression of this topic, but it does help make these ones nice and quick. You can just go across 1, up 3, cross 1, up 3, and you can just draw all these points in and join them all up. Okay, so this is what the graph is actually going to look like. And if we go across 1, down 3, there we are, there's our next one. So we could actually just draw this straight in, and it's a nice quick way of getting these drawn, but I'm going to get rid of that because it's not going to help us really with understanding this at the moment. So if I draw my x and y coordinates, x and y, and this one is 3x minus 2. So it says from -1 to 3, so -1, 0, 1, 2, 3, and again just sub in the points into the equation. So if I start with -1 again, let's just do this one to start with. So for -1, we have 3 lots of -1, and then take away 2. 3 lots of -1 is -3, take away 2 is -5. There we go, so -1 is all the way down here at -5, and we can put that into our little table. It's up to you if you want to draw the working out for all of them. I'm just going to follow this in my head now. So from 0, let's triple that, is 0. Take away 2 is -2. There we go. And again, we can start to look at the pattern here. And you'll notice it goes up by, again, this gradient, which is 3. It's going up in 3s. So if we just keep adding 3 each time, okay, because it's just a bit of a sequence here, a bit of a pattern, just plussing 3. And then again, add 3 for the next one. And just continue that little pattern, and that's fine. That's a nice quick way of getting these drawn. So add 3 to -2 is 1, add 3 again is 4, and add 3 again is 7. And then plotting all of these, so 0 minus 2, and there's that -2 that we knew we were going to get. 1 to 1, 2 to 4, and 3 to 7. There we go. Right. So this actually does say draw it from the x values from -1 to 3. So I am going to start from the one on -1. I'm going to connect it with a ruler and a pencil if you're doing it on paper up to the final point, but I'm not going to extend it this time because it just says to draw it between those two x values. Okay, so I don't need to extend it beyond the points. You don't need to label it, but it's, you know, if you want to label it, that's absolutely fine. You can just label it as y equals 3x minus 2. There you go, but don't feel that you have to do that. It's not, you know, unless you're explicitly asked to label it, you don't have to. Okay, so in this question we are given a line already drawn on a graph, and it says write down the equation of the line. Now we know already that what the equation of a line is going to look like. It's in this format, y equals mx plus c. Again, that c being the y-intercept. Now we can see the y-intercept on the graph. It's over here, 5. So for starters, I can actually just draw that straight in. We can say c equals 5. And we can just put that in our line equation. So y equals mx plus 5. All we need to figure out is what the gradient is. Now if we have a look at this question, we've got to find some coordinates that we can actually see. So here's another coordinate that's on the line, 1, 3. Now if I want to find a gradient between these 2 points, all I have to do is draw a little right angled triangle in. So I can go across or down from this red point, but if I go across and then down, I'm just going to say how big the movement is there. So that's a movement of 1 there, and then that's going down 2, so I'm going to say that that's -2. Now the equation to get the gradient, there's 2 different ways that you can look at it. You can have a look at it, and it's just use this little triangle. It means the change in, so it's the change in the y coordinate over the change in the x coordinate, and it's sometimes referred to as rise over run. Okay, so you might know one of these two, but change in y over change in x, or rise over run. Now in this case, look, the change in the y coordinate is this movement here going down, it's -2, so that'll be on the top of my little fraction here, -2, and the run, or the change in x, is on the bottom there, is the 1 going across, so it's -2 over 1, and -2 divided by 1 is -2. Okay, so my gradient here is -2. So it's obviously sloping downwards, which is why it's got a negative gradient, but that's what our gradient actually is for this question here. So all I've got to do is put -2 in place of m, and we get y equals -2x plus 5. Obviously thinking about that last question that we looked at, you could actually write that as 5 minus 2x, but you can write it in either way, it's absolutely fine to do so. Just a little side note, you can actually do these triangles as big as you want. If I picked some different coordinates, let's have a look, that one there and this one here for example, and if I was to go down instead and make a big triangle like this, let's have a look, my run there is 4 and my rise goes from 7 down to -1, which is a movement of -8, and if I did rise over run for this one, or the change in y over change in x, it would be -8 over 4, and -8 divided by 4 is -2. So you can do this however you like, okay, because it's a straight line, it doesn't actually matter where you do the gradient from, it's just you just need to draw it in, just read those numbers very, very carefully so you can get the correct gradient there. Okay, so looking at drawing some shapes, and there's lots of different options for ways that you could draw these, but this is on the grid, draw a parallelogram. Now when we're drawing a parallelogram, we do need all those pairs of sides to be parallel, so we're going to draw one pair of parallel sides, and they have to be just off. Now if I was to just draw it straight underneath like this, that would be a rectangle. So with a parallelogram, it's almost a little bit slanted, so I just need to draw the same size line, so 5 squares across, but not perfectly underneath it. So there we go, 1, 2, 3, 4, 5, and then those lines are parallel, and then the connecting lines as well, this one and this one, will also be parallel, and you can put parallel symbols on there if you want, although as long as the parallelogram is drawn perfectly, you don't actually have to add those on. But if you have a look, it's just very important that when you join these up, this point and this point here have the same distance pattern between them. Okay, obviously I'm going to get rid of those because then it wouldn't be a parallelogram anymore, but you can see the pattern that you have to do in order to draw one perfectly. Now for the next one, it says to draw a kite, and to draw a kite we need to create, let's just have a think how I draw it. We know what a kite looks like. It looks something like this, where these two sides are the same length and these two sides here are the same length. So obviously I could draw this any size, so I'm going to draw the top bits to start with. I'm just going to go from there to there, and then the same pattern the other way around, so there is that line of reflection going down the middle that we have in a kite, and I'm going to do all the way down to the bottom of the grid, so we'll go down to here, down to there, and as well you could add these lines on if you want for a kite, although again, as long as it's drawn perfectly you don't have to add those on. So there we go, that is a parallelogram and a kite. A kite should have those two sides of equal length at the top, two sides of equal length at the bottom, and that perfect reflection line down the bottom, so it's the same either side, and your parallelogram there on the left. So there we go, there's a couple of different shapes that you could have to draw. Okay, so this question says to draw and shade a sector of the circle. So a sector makes a nice sort of like pizza slice shape, so we draw from the centre out to the circumference there, and we could shade that in, and that would be our minor sector. You could actually shade in the outside of that, and that'd just be a major sector as well. It doesn't dictate which one we need to shade, just says to draw a sector. So there we go, there is a sector. And for the next one, it says to draw a segment. Now a segment is created by drawing in a chord, so we're going to draw a chord in, and it makes this sector here, or this segment, sorry, and there we go, that is a segment. So there's a couple of other bits that we could draw on here. Obviously the sector here is made using a radius, so you actually drew a radius in there to create that, and the segment was made by drawing in a chord. So there's a couple of other bits of circles as well, but you could also be asked to draw a tangent, which is a line that just touches once on the outside and carries on going, and you could also be asked to draw in a diameter as well, and then a diameter is just a chord that goes through the center. Hopefully you already recognize what a diameter looks like. But there we go, there's a few different parts of circles that we could be asked to draw. Let's have a look at our next question. Okay, so this question says work out the length of BC. Let's just identify that there. So the length BC is this length across here. And it says give your answer correct to 3 significant figures. Now straight away it doesn't actually stand out that you definitely need to use Pythagoras for this, but we are working out lengths, and Pythagoras is one of the skills we have to work out lengths in different shapes. Obviously only when it comes to right angled triangles, but different shapes, if we can find a right angled triangle somewhere, we can apply Pythagoras to help us work it out. And in this type of question, look, if I chop from the D down to the base, that creates a right angled triangle here on the right, and we have a rectangle on the left. Now because it's a rectangle on the left, we can say that the 2.1 there is the same as the 2.1 down here, and that's in meters, and the 1.9 there is the same as the 1.9 over here. Now that means that we've got enough lengths in this right angled triangle. Now we've got the 3.2 and the 1.9 to work out the lengths down the bottom here, which I'll put a little X next to. And then once we've got that, we can combine it with the 2.1. So looking at that right angled triangle we've got the hypotenuse look opposite our right angle. So we're going to do square, square, and then minus, and then root. So 3.2 squared, take away 1.9 squared. We'll work that out and then root the answer. So on the calculator, 3.2 squared, take away 1.9 squared, and that equals 6.63. There we go, 6.63. So square rooting that, so 6.63, the square root of that, and that equals, let's have a look, 2.5748. 2.5748 and a few more decimals. Now again, it says it wants our answer correct to 3 significant figures. Obviously just make sure you read that. So if we round this to 3 significant figures, we get 2.57. There we go. And this is in meters this time, so 2.57 meters, and I can label that down here, 2.57 meters. Now I can work out the full length of BC there, because we've got the 2.1 and the 2.57, and if we add those together, 2.1 plus 2.57 comes out as 4.67. So let's just write the working out for that down up here. 2.1 add 2.57. I should probably tidy that up with a 0, and that comes out as 7, 6 and 4. So 4.67 meters, and there is our final answer for that question. Let's have a look at one other kind of question similar to this one. Okay, so this question says work out the length of AC and give your answer correct to 3 significant figures. Now if we have a look, just to start off with, if I was to connect A to C, it would form this length right here. And that obviously just starts to throw things up a little bit. So I'm actually going to take a slightly different approach to this to start with, because if you have a look, the right angled triangle that we've created here, we've got the 9, we've not got the hypotenuse, and we've not got BC. So because I've only got one missing length in that triangle, it's pretty useless for me to have a look at it at the moment. So there must be another length we can find first. So if I come back to this and let's have a look. Looking at what we've got at the moment, if I try and find a right angled triangle somewhere, I can do that this time by chopping across. And if we chop across there, we might be able to work out this length down here. Obviously that was the base of the big right angled triangle we've just drawn. Let's have a look if we can do. Now we've got a rectangle on the bottom. We don't know the top and the bottom, but we do know that the 3 over here, which must mean this is 3 over here. And the full length of AB, this length here, it says is 9. So if that part that I've just drawn in is 3, this top bit here must be 6. And that now means that in this right angled triangle, we've got 2 of the missing lengths, and we can work out that dotted line there, which is going to be the same as x down the bottom. And I can do that again using Pythagoras. We've got the hypotenuse there, which is 10. So we can do 10 squared, take away 6 squared, and 10 squared take away 6 squared is 64, I believe. Let's just have a check. That's 100 take away 36, which yes is 64. Okay, so that's quite a nice one because we can square root that without a calculator, and the square root of 64 is 8 centimetres. There we go. So this length here, and let's do that in a different colour, is now 8 centimetres. That is not a C, that's a backwards C. I think I was going to write 8x there, so 8 centimetres. And that is the same as the x down the bottom, 8 centimetres as well. So now we've got that. And again, I've had to do a bit of drawing over the diagram here, but if we get rid of this now, and we have a look at what we've now got the base of that right angled triangle that I drew in initially. And if we connect up A to C, look, and I've not done that very well there, it'd be handy if I could do this with a ruler. But A to C, there we go, has now formed this big right angled triangle. And if I just highlight that, we've got a big right angled triangle there, which we now have two of the missing lengths for. We've got the 9 on the side, which was the full length that we had initially, and we've now got the 8 centimetres down the bottom there, which we can now use to work out the length of that hypotenuse, which is the length AC. So to work that out, just a nice bit of Pythagoras here. Look, we're trying to find the longest side. So we've got 9 squared plus 8 squared, and 9 squared plus 8 squared, and this is a calculator question because it says 3 significant figures. It comes out as 145, and we need to square root 145, and the square root of 145 is 12.0415. There we go, 12.0415 and a few more decimals. Now to finish this question off, we've just got to round it. 3 significant figures, so 1, 2 and 0 is my third, and that 4 isn't enough to round it up, so it goes to 12 point, and here's a good little tip here, look, we have to keep the 0 in there. That is our third significant figure. So although we wouldn't normally write 12 as 12.0, it's asked for 3 significant figures, so we do have to keep the 0 in there, and that is centimetres, and there we go, and there's our final answer, 12 centimetres. Okay, so it's just thinking about a different way of using Pythagoras. That one there was a little bit trickier because we had to go in 2 steps and work out a different line before looking at AC, but there's just something to be thinking about. Okay, so this says Dave is a cleaner. It says the table shows some information about the time it will take him to clean each of the 4 rooms in a house. He wants to clean all 4 rooms in one day, and he's going to have breaks for a total of 75 minutes. He's going to start cleaning at 9 AM. Will he be finished by 4? And you must show you're working. There's a couple of different ways that you could do this. You could start at 9, and you could start adding all of these times onto 9 and figuring out the time as you go along. Or, of course, what we could do is we could work out how many hours there are between 4 PM and 9 AM, and then just add them all up and see if it's more or less than that number. I think that's probably the quickest way for this question, so that's how I'm going to do it. But of course you could take another method. So from 9 AM to 4 PM, that is, well, it's 3 hours until midday and another 4 hours. So in total, that's going to be 7 hours. So if we write that down, that is going to be 7 hours between those two. So we just need to add all of these up and see if that's going to be more or less than 7 hours. Now to start with, we don't want to forget about this 75 minutes. So I might just add that over to here. And while I'm doing that, I'm just going to write it as 1 hour and 15 minutes. There are 60 minutes in an hour, so I'm going to write 1 hour, 15 minutes, and that's the break. So I'm just going to put the break down there. Right, so we need to add these all together. So let's go step by step. We've got 2 hours. I'm going to add all the hours up. We've got another 1 hour. So that's 3 hours. We've got 1.5. To be fair, we could add that in one go. So let's go for 4.5 hours, adding all of those. We've got 5.5 hours when we add this hour here. We could add then the 45 minutes, and the 15 is another hour. So you might want to just start writing these down so that you don't forget them as you go. So that we had the 2 hours plus the 1, which got us to 3 hours. Then we had the 1.5 hours, so 4.5. The other hour, so 5.5. We've now got the 45 minutes and the 15 minutes, which is another hour. So that's 6.5 hours. We're very close to that 7 hours. And the last bit we've got to add is the 40 minutes. So if we add 40 minutes on, we're at 6.5, which is 6 hours and 30 minutes. So if we add 40 minutes to that, that's going to go to 7 hours and 10 minutes at the end. So that's gone just over our 7 hour limit. So in terms of this, will he finish by cleaning by 4 PM? No, because he will finish at 4:10. There we go. No, he will finish at 4:10 PM. Okay, so there's our final answer. Now, obviously I chose a particular way of adding those numbers together. You can do any particular way that you want here, but as long as you're getting 10 past 4, then your method's obviously absolutely fine, but 10 past 4 is the answer there, so no, we will not finish at 4 p.m. It says Ben is going to cover the floor with wooden floorboards, and it gives us a diagram of the floor. It says one pack of floorboards will cover 2.25 metres squared. How many packs of floorboards does Ben need? So the first thing that we actually want to work out here is the area of this compound shape. And there are two different ways of doing that. So as you can see, it's this kind of L shape at the moment, and it's made up of two rectangles. So we have to split this up into individual rectangles so we can work out their areas. So you have two ways of going about that. You could go across and you could split it up into rectangles that way, or you could go upwards and you could split it into two rectangles that way. Of course you could do both and you could split it into three rectangles, but that's probably going to make a little bit more work for yourself. So let's just go with splitting it across and working out the area of these two. So for the bottom rectangle there, you have a length and a width of 3 and 2. So that's going to give us an area of 6 metres squared. Again, just doing 2 times 3. For the top one, you have a length and a width of 4.5 and 2. So if we do 2 times 4.5, that is going to give us an area there of 9 metres squared. So overall, we can work out the actual total area. And 9 and 6 is going to give us a total area of 15 metres squared. Again, just showing you're working out and how you've added them together. So the area of the floor is 15 metres squared, and it said in the question that one pack of floorboards will cover 2.25 metres squared. So in order to work out how many packs that we need to buy, we have to do 15 and divide it by the 2.25. So if you have a calculator, you can just type in 15 divided by 2.25, but if not, you are going to have to just count up in 2.25s. So what you could do is just start making a list. You could do 2.25 plus another 2.25, which would be 4.5, and you could build your way up. But if we do this on a calculator while we're practicing, you'll see that you get the answer 6.6 recurring. Now obviously we can't go into a shop and buy 6.6 recurring packs. So when it comes to a question like this, we have to actually round that up. The reason that we have to round it up is obviously if we were to buy 6 packs, then we wouldn't have enough. And if we were doing this in real life, we would have to just buy more packs than needed, and we would have some spare left over at the end. So when we get this scenario, we will round that up and we would say 7 packs, and that would be the final answer for this question. Obviously the question could go a little bit further. It could tell you the cost of each pack and potentially ask you to work out the total cost of buying them. So you have to remember to round it up, because in real life, again, we would have to buy the additional pack there, which would give us some left over, but that would be absolutely fine. So this question here. Now this is an interesting one again, because it's not necessarily a compound shape. Now before we read the question, you can see that what we have on the screen is a trapezium, but a trapezium could be viewed as a compound shape if we split it up into a rectangle and a triangle. Now hopefully we're not going to have to use that for this question, but another one of these functional type questions here where we are looking at grass seed instead of something like varnish or floorboards. So this question here says Jane wants to cover her lawn with grass seeds. One bag of seed will cover 20 metres squared, and each bag of seed costs £4.99. Work out the least cost of putting grass on Jane's garden. Okay, so for this question we're going to have to work out the area of this shape. Now thankfully we do have the height of this shape, so we could use our area of a trapezium formula. And we know with the area of a trapezium that you do the parallel sides added together divided by 2 and then multiply it by the height. And remembering that formula, which we looked at in a previous video, which I will link here for you, is half a plus b and then multiplied by the height. So if we plug those values in, we have 12 plus 18, which is equal to 30. We would divide that by 2, which is equal to 15, and then we would multiply it by the height. So we need to do 15 times 9, and when you work out 15 times 9, you get a final answer of 135. And this again is in metres, so that is 135 metres squared. And again, you can take your time working that out. So now we have the area, we need to work out how many bags of seed she needs. Now it again said that one bag of seed covers 20 metres squared. So we would need to do 135 and divide that by 20. Now again, if you do that on the calculator, or you could just count up in 20s, but if we do 135 divided by 20, we actually get the answer 6.75. So we know that we have to get 6.75 bags. But again, it comes down to that issue where if we have a decimal amount, then we're going to have to round that up, and we're instead going to buy 7 bags of seed. Okay, so now we know how many bags that we need, we can multiply that by the £4.99. It says each bag of seed costs £4.99, so we just need to work that out. So I'd do 7 times £4.99, and again, if you don't have a calculator for this particular question, you could do 7 times 5 and then take away the 7 extra pennies there. 7 times 5 would be 35, take away the 7 pence would leave you with £34.93. Again, if you don't like that method, then you can hop the decimal out and you could do 7 times 499 and then obviously hop the decimal back in 2 jumps. So both answers, both methods there would give you this £34.93, but again, if you had a calculator for this, that would be nice and easy because you would just type it in. So the least cost here that it's going to cost is £34.93, and that comes from buying the 7 bags. Obviously we're going to have a little bit left over there, but it doesn't say that the bags can be sold in particular portions. You do have to buy the entire bag for £4.99 and just have some left over. So we're going to start with this question here, and it says in a bag there are only red, blue and white counters, and a counter is taken at random from the bag and the table shows the probability of each colour. Obviously though, we can see we are missing a colour, we're missing the probability of white just here, and we'll have a look at that in just a sec. It then says James is going to take a counter, replace it and take another, and he does this 50 times. Estimate how many times he'll take a white counter. Now obviously we don't know the probability of white, but we can actually work that out. Now when I look at these probabilities in a table, I like to think of these decimals here as percentages in disguise. So this one here, 0.5 is 50%, okay, and we can look at that as a percentage instead of a decimal. Blue we've got there as 0.3, and that's 30%, there we go. And that is our second percentage. Now, all of these probabilities have to add up to 100%. So at the moment, we've got 50% and 30%, and that adds up to a total of 80% at the moment. There we go. So we're missing 20%. So that missing 20% is our decimal for white, okay? And obviously we're writing this as decimals, so if we want to have a look at it in just in terms of the decimals, we could think of it as 0.5, add 0.3, that gives us 0.8. If we look at it in terms of the decimals, there we go. So to make that equal 1, we are missing out on 0.2. So the probability of white is 0.2, or logically, if we think about it, that's 20%. Now the reason I think about it in terms of a percentage is because it's going to help us further down the line with some of these questions, and it's going to help us with this second part of this question. So it says he takes a white counter 50 times. So if he takes the white counter 50 times, we would expect him to take a white 20% of the time. Sorry, he doesn't take a white counter 50 times, but if he takes a counter 50 times, we would expect it to be white 20% of the time. So really all this question is asking us is to work out 20% of 50. Okay, so all we've got to do is pick out that little percentage question. So really we just need to find 20% of 50, and we can do that quite nice and easily. Always find 10% to start with, so 10% of 50 equals 5, and 20% is double that, so 20% is going to equal 10 times. There we go, and there's our final answer, 10. Now just another note on this, it does say that word estimate. Now normally the word estimate does mean to round, doesn't it? It means to round to one significant figure and make a little bit of a guesswork. Now in this scenario here, the word estimate is just because we are using the probabilities in order to do so. Okay, it's like when we flip a coin, it's a 50-50 chance that we'll get a head or a tail, but if we flip it twice, we're not necessarily going to actually get a head and a tail. We could get 2 tails, okay? So that's what the word estimate means in this scenario. It just means the fact that we are using the probability in order to make our best guess on how many counters or whatever the question's about we're actually going to get. So there we go, that's this question sorted. Find the missing decimal in the table. Obviously you can think about that in terms of a percentage or in terms of a decimal. They've all got to add up to 1, or they've got to add up to 100%, depending on which way you want to look at it. And then you just need to have a look at the second part of the question, have a think about what percentage of what it's actually asking. So in this circumstance here, it said 50 times, and for the amount of white counters, we identified that the white counters was 20% or 0.2, and therefore we could get 20% of 50 there. Now if you have a calculator, there is a nice quick way of doing this. I don't think it necessarily helps for the progression of this topic, but there is a quick way of doing this as well. You could just do 50 and multiply it by 0.2, And that just on your calculator basically is just a calculator way of saying work out 20%, okay? So it is the same process, but you'll get the same answer there. So you can just do a little bit of a shortcut if you want to take a nice quick approach using a calculator. Now when it comes to independent events, we're going to talk about it throughout the video, but an independent event is just two events where the second event is not affected by the first event. And we'll have a look at why it's not affected in these types of different questions, but it's just, that's all it means there. It just means that the one event that we're looking at is not going to be affected by the other. So let's have a look at this question. Now, in a lot of these questions, you'll normally actually be given a tree, but in none of the ones that I'm going to have a look at, I'm actually going to give the tree. We're just going to draw them all ourselves, because obviously if you're not given the tree, it's important that you're able to do that anyway. And if you are, then that's easier for you. So we're just going to have a look at these slightly harder questions here. So James has a bag of counters, and in the bag there are 4 red and 5 blue, and James takes at random a counter from the bag and notes its colour. He then puts the counter back in the bag, and that's an important bit we're going to discuss there, and takes at random a second counter. And we're going to work out the probability that James takes 2 different coloured counters. So that line there where it says he puts the counter back in the bag, that there is what determines that this is an independent event, because after we take the first counter, if we put one back in the bag, the second time we're just taking a counter from exactly the same bag of counters. So it doesn't actually matter whether we take a red or a blue. So let's have a look at constructing this via a tree. So if we draw a little tree here, we're going to draw 2 branches that represent red and blue. Okay, and that is going to be representing our first pick of the counters there. I'm going to label this part of the tree, so that's the first time we take a counter. Now let's write the probabilities in. So looking over there, we've got 4 red and 5 blue. So in total there we've got 9 counters. So you can do that working out to the side if you want. 4 plus 5 equals 9. So if we're going to write the probabilities here, I'm going to write them as fractions, just keep it nice and easy. Obviously you can write it as decimals if you like, but I think in the case of this question it's probably easier for us to write it as a fraction. So for red, it's 4 reds out of 9. So the probability of getting a red is 4 out of 9. And then we've got blue, and that is 5 out of 9. There we go. And just thinking about these fractions here, obviously if you were given the tree and you were you didn't have the information up there and it said that the red was 4/9, you'd have to actually work out the blue there, and obviously the numerators have to add up to whatever that denominator is. If it's 4 out of 9, that tells you there's 9 counters, 4 of them being red, and therefore 5 of them have to be blue in order to make 9 out of the 4 and the 5. So just thinking about that, if you weren't given the the information in the question, you'd have to actually do that yourself on the tree. Now obviously what we have the little scenario here, and I always like to think of it as a bit of a journey. So if we imagine a little person standing over here at the start, not the best drawing there, but we could either go on a little journey. Now we could take a red out of the bag, in which case our little person would end up here, and then we'd have our second counter. So at this point we can construct the second part of our tree, and I'm going to run out a little bit of space here, and this is going to represent the second pick. Now on this second pick here, look at this part of the journey, we've taken a red counter, and now we're going to take another one, and again that can be red or blue. And because the counter's gone back in the bag, again it's going to be 4/9, and it's going to be 5/9 again for blue. And that is that one part of the journey. But of course we might not have taken a red out, so if we get rid of our little person here, and let's imagine that actually instead we've taken out a blue, and we've gone down this part of the journey here, we've taken out a blue counter. So here we are, we've taken out a blue. Now again we're going to take a second counter, okay, and that again can be red or blue, so we'll label that up, red or blue. And again the probabilities are just going to be exactly the same. It doesn't matter whether I took a red or whether I took a blue, it's still 4/9 and 5/9 as that counter has been put back in the bag. So we've constructed our tree, and let's have a look. Let's just get rid of all of this. We now just need to work out this probability, and now the question says work out the probability that James takes 2 different coloured counters. And there are 2 ways that I can actually do that. So to get different colours I could, and I'm just going to squiggle along the lines, and this is how I do it. I go up the red, and then I'd have to take a blue. And the 2 probabilities that you go through on this journey are really important. So we went through 4/9 when we took the red, and we finished on the 5/9. So to work out the probability of that route happening, all we do is we multiply those 2 fractions together, and all you've got to remember is you times when you go across the tree. So if we times them together, we've got 4/9, and we're going to times that by 5/9, and that's really nice and easy. Not to forget, when you're multiplying fractions, you multiply the top numbers, so 4 times 5 is 20, and 9 times 9 is 81. So the probability of getting a red and then a blue is 20 out of 81. Now, not that that one can simplify, but you do not need to simplify fractions when it comes to probability, and the reason being is that that probability there, 20 out of 81, tells us something quite important. It tells us that there are 20 different ways of this happening out of a possible 81 different ways of picking all these counters. That can seem a little bit hard to understand sometimes, but if we labelled the red ones 1 to 4 and the blue ones, let's say 1 to 5, there are 20 different ways of taking a red than a blue. I could take red counter number 1 and then blue counter number 1. Or I could take red counter number 1 and then blue counter number 2, etc, etc. Obviously they're all still red and blue, but if they had different numbers on and we think of them as, you know, all different counters, then there are 20 different ways of doing that. Now what we're going to have a look at now is the other way of getting two different counters, because I could take, instead of a red then a blue, and let's think, I'm just going to do a different colour here, I could take a blue and then I could take a red. And that would also give me different colour counters. And again, that goes through these two different fractions, so 5/9 and 4/9. And if we times them together, you'll probably notice here that actually we're going to get the same answer because it's the same two fractions in reverse. And 4/9 times 5/9, again on the top we get 20, and again on the bottom we get 81. But that there is taking a blue then a red. Okay, and there are 20 ways of doing that as well. So there are 20 ways of getting a red then a blue, and 20 ways of getting a blue then a red. So the total probability there, in order to get our final answer, we just need to add these two together to combine them to get the total probability there. So 20 plus 20 on the top gives us 40 out of the possible 81 ways. Remembering you don't add the denominators together there when adding fractions, and that would give us our final answer, 40 out of 81. Okay, so a few different things to be thinking about there. One was constructing the tree, thinking about obviously our first pick and our second pick, and then the next one was obviously multiplying across the tree, and any different combinations that we have at the end, we just add them together and combine them together. Of course, you might get a nice easy question here. It might just say, what's the probability of taking two reds? In which case you only need to do the one journey. Have a look at the tree there, that goes through the 4/9 and the 4/9. So you just times them together and that'll be your answer. But if there are multiple answers, you just need to think about adding them together at the end. So let's have a look at a slightly different question. Okay, so this question here says Mary has two bags of counters. In bag A there are 3 red and 2 blue, and in bag B there are 4 red and 3 blue. It says Mary takes at random a counter from bag A and notes its colour. She then takes at random a counter from bag B. Work out the probability that Mary takes the same coloured counters. Now again, this is an independent event because they're two different bags. It doesn't matter whether we take a red out of bag A, that's not going to affect the probability in bag B because that's a completely separate bag. So again, we can construct a tree for this. Now it starts talking about bag A, so I'm going to start with my tree being about bag A, and I'm going to label that up here, bag A. There we go. And again, it's red or blue. Now I've decided to stick with red and blue counters for all of these questions here, but there could be any sort of different combination of counters or pens or anything, or marbles it sometimes goes on about. We just need to make sure we read the story and construct our tree. So for red, there are 3 reds and there are 2 blues. That's out of 5 in total. So for red it's 3 out of 5. And for blue, again, it's 2 out of 5, remembering obviously that those numerators have to add up to 5 in this scenario if you weren't given the information. So that's our pick out of bag A, and then we've got to have a look at bag B. So again, I'm going to label the second branches of the tree over here bag B, but again we have 2 different scenarios. Now we could take a red, in which case we're looking at this part of the tree, and again it's a red or a blue. And in that second piece of information there, let's highlight that, there are 4 reds and 3 blues. So there'd be 4 out of 4 plus 3 is 7, so 4 out of 7 this time, and it'd be 3 out of 7 for the blue. Of course, we could have taken out a blue out to start with, so we could be on this part of the journey, and again, there'd be a red or a blue, but nothing's going to change down there. It doesn't matter whether we take a red or a blue out. Red and blue are going to stay the same, so it's still going to be 4 out of 7 and 3 out of 7. And there we go, that's our tree constructed. And again, just thinking about obviously those second little sets of branches there, both are the same top and bottom, as it's an independent event and it doesn't say anything changes. You know, it might say if so-and-so took a red in bag A, that the probability changes in bag B. If it doesn't state anything though, we always just assume that it's always going to be the same there, as it doesn't say anything's going to change. So it says here, work out the probability that Mary takes the same coloured counters. So again, just thinking about the logic here, like before, we had red, blue and blue, red for different coloured counters. This time it's the same coloured counters, and there are 2 ways of doing that. We could get a red, going through the 3/5 there, and another red going through the 4/7. So that is our two fractions that we're going to have to multiply this time. So if we do those, we get 3/5 multiplied by 4/7, and again times in the top gives us 12, and times in the bottom gives us 35. So there are 12 out of 35 ways of getting two reds. And then obviously thinking about the fact of the same colours, we could have two blues. So if I go through blue 2/5 and through the other blue 3/7, that's going to give us our second probability there using those two fractions. So if we write those down, we have 2/5 multiplied by 3/7, and that gives us 6 on the top and 35 on the bottom. So telling us there's 6 out of 35 potential ways of getting two blues. And again, finishing this question off, we've got two probabilities that we need to add together. So I'm just going to write down the sum this time. We've got 12 out of 35, and we need to add to that 6 over 35, and 12 plus 6 is 18, and that is out of 35. Again, remembering not to add the denominators together there. So 18 out of 35 is going to be our final answer for this question, as our probability of getting the same colours. Remembering again though, you could get a nice easy one. It could say what's the probability of two blues, in which case we'd have just gone along that purple route and got 6 out of 35. Okay, so just thinking about obviously the slightly harder style questions here rather than just one straight route. Okay, so if you're able to do these, you're able to do most of those questions there.
The great thing about a pie chart is that all of the numbers in the question that we're going to have a look at need to add up to 360. We know that around a point in a circle all the angles add up to 360. So that in order for our pie chart to work, it has to add up to that number. So if we look at our question, we're going to find the numbers that are associated with our question. We're going to get the numbers to add up to 360, and then we're going to draw it using our protractor. So we're going to run through all of that. I've got a question for you to practice and one final question for us to have a look at, but it's going to be a relatively quick video looking at drawing pie charts. So this question here says the table gives information about the languages studied by a group of Year 11 students, and it says that 30 study French, 37 study German, and 53 study Spanish, and it says draw an accurate pie chart for this information. So the first thing we want to do is add up all these numbers. So if we add up 30, 37 and 53, let's have a look, that adds up to 120. And I always just write that down over here somewhere near the table, just so I know what the total is, and the total there is 120. So in order to get this to 360, either you just have to think about that in your head, what you multiply 120 by to get to 360, or we could just do 360 and divide that by the total there, which is 120. So 360 divided by 120 is 3, meaning that we're going to have to multiply all of these by 3 to get the angle in each portion of the pie chart. So if we multiply them all by 3, and we'll just write times 3 next to them all, there we go, times 3 times 3 times 3, that would mean that 30 would become 90 degrees, and these are our angles now. We would have 37 times 3, which would be 111, so that would be 111 degrees, which is a bit of an awkward one to draw, and 53 times 3 would be 159, so that is 159 degrees. Now that is the main bit of our working out now. We know all of the angles that we need to draw, we just actually need to draw them on correctly. So when you've got your pie chart drawn like this, if it's given to you, if not, you're going to have to use a compass just to draw a circle. And if you're making notes on this, I would definitely do that. Just get your compass, draw a nice circle, just make sure that you know where the centre of that circle is, so that you can draw this nice straight line going up so you have a place to start from. So let's start with drawing on this French one, which is 90 degrees. We can put them all in at the same time, but let's do the first one. So get your protractor, pull it over the top of the pie chart, make sure that little crosshair in the middle is right on the centre. And there we go, just do that really nice and carefully. And then you also want to rotate your protractor so that the guideline where it starts at 0 is lined up with the line that you're starting from, which is the one that's vertical. So there we go, that's nicely lined up. So I want to mark on 90 degrees. So I'm just going to mark the 90 degrees over there. There we go, pull your protractor out of the way. And then with a ruler and a pencil, from that central point, draw a nice line over to that. And you can obviously do it a little bit shorter, just to the edge of the pie chart. And there we go, that's your 90-degree angle. Now you can move on to the next one. But before you do, what I tend to do is I normally tend to label that section. So I'm just going to put French in there. So I'll put French in, and I'll also put the degrees in there, 90 degrees. You could also put the 30 in there as well, but just to keep it a little bit simpler on the screen, it's going to leave it as French with the 90 degrees. Okay, so putting your protractor back onto the centre, Now we just want to rotate the protractor around so that the 0 is lined up with our new line, so we can carry on from that point. And again, I'm using the outside numbers. And now we need to do 111 degrees. So past the 90, 110, 111 is just past that, and you're going to have to just get it as accurate as you can. There we go, there's 111 for me. Again, just pull that protractor out of the way, and we can draw in a nice straight line again from the centre. So from the centre, ruler and a pencil, join it up. I'm just going to shorten it a little bit. There we go. You can do that a little bit easier when it's not on a screen, but there we go. Using your ruler and a pencil, I'm just going to label that. So that would be German. And that was 111 degrees. There we go. And the last part of the pie chart here, which, as we only have one left, is Spanish. So we'll label that as Spanish. And that is 159 degrees. A good bit of practice here that you should do is you should stick your protractor on, just measure that final angle there. So I'm going to flip it around the other way, measure to see if that's 159. Might be a little difficult for you to see on the screen there, but that comes out as around 159 for me. So I'm happy with that. It's an accurate pie chart. All of the angles match up to what I wanted them to. And there we go, there's your pie chart. Okay, so that's how you go about drawing it. That's how you get the angles. Remember, they've got to add up to 360. So that bit of working out there where I added up the total and did 360 divided by that total allowed me to see what I needed to multiply all those numbers by so that they all added up. And another good bit of practice that you could do is take those three numbers and just add them up, and you can actually see 159, 111 and 90 do all add up to 360. So we've definitely got it right. Okay, so there we go, that's how you're going to do it.
Okay, so looking at some mean and range. Now part A here says work out the range of the numbers on these cards. So we've got all the cards at the top. To work out the range, we want to do the biggest take away the smallest. So the biggest number on the cards right there is 8. The smallest number on the cards is 1. So we just write that working out down. 8 take away 1, which is 7. So the range on the cards is 7. The next one asks us to work out the mean. So to work out the mean, we need to add them all together. So if we add all of these up, 3 plus 1 is 4, 5, 6, 7, 8, 9, 15, 23, 32. So they all add up to 32. So to do the mean, we do 32 the total, divide by how many cards there are. There are 1, 2, 3, 4, 5, 6, 7, 8. So 32 divided by 8, and that is equal to 4. So our mean would be 4. So there we go, that's how you work out the range, biggest take away smallest, and to work out the mean, get the total, divide by how many there are. And there we go, there are our averages.
So it says here there are 10 boys and 20 girls in a class, and the class has a test. It says the mean mark for all the class is 60 and the mean mark for the girls is 54. Work out the mean for the boys. So when it comes to a question like this, obviously we know, or hopefully we know, that when we're normally working out a mean, we get the total, we divide by how many people there are or how many things there are, and we get our mean. Okay, so we do the total and we divide by the amount, okay, for whatever it is. There we are, on its most basic sense there with the mean. You do the total divided by the amount. Well, in this question here, obviously it doesn't actually give us the total. It tells us what the mean is, it tells us the amount, it tells us that there are 10 boys and 20 girls, but it doesn't actually tell us the total. So what we're going to do is we're going to go backwards to work out some of these totals, okay? So we're going to think about this in reverse, all right? And that is how you get the mean there, the total divided by the amount. Okay, so if we link some of these things up, then it says that there are 10 boys. It doesn't give us the mean for the boys, so that's no good so far. So that first piece of information that we are actually given in terms of the mean, it says the mean mark for the whole class is 60. Well, if we were going to work out the mean for the whole class, we'd get their total. Let's call that X. We divide it by the amount, and in this case the whole class, well, there's 10 boys and 20 girls, so we would divide it by 30, and it would give us this mean here, which it says is 60. So in other words, we're looking for a number that divides by 30 that gives us the answer 60, and we can just do that in reverse. We can just do 60 times 30. So actually all we're going to do in these questions is we're going to link the mean that we're given with the amount that is appropriate for that mean. So I'm going to get rid of this little bit of algebra that I've drawn here, but obviously you could think of it in terms of an equation, but this is the sort of concept that we're going to run throughout this question, and hopefully once you actually get your head around this and why we multiply instead of divide, obviously we are doing a reverse. This question obviously becomes a lot easier then. Okay, so obviously thinking about this topic's actual name, it's called a reverse mean. Normally when you work out the mean, you do a divide, and obviously then the opposite or the reverse of dividing is multiplying, and in these questions we're going to be multiplying rather than dividing to go backwards. So let me get rid of that. So let's have a look. So obviously we've been given that the mean for the whole class is 60, and we've just established that there's 30 students or 30 people in the whole class. So we're going to do 60 times by those 30 students, and that's going to tell us their total. So 6 times 3 is 18, add on the 2 noughts, that's 1,800, and that is the total for the whole class. And it's usually worth just labelling these, particularly if you haven't quite got your head around it. Let's just label that total for class. There we go. Right, so the next bit of information then, we've also been told that the mean mark for the girls is 54. Now, in terms of the question, look, there are 20 girls. So if there's 20 girls and their mean is 54, we'll take their mean, 54, times it back by that 20 to find out what their total was. So 54 times 20, there we go, and that gives us 1,080. And there we go, there is the total for the girls. And let's just label that again. Total for girls. Right, so just thinking logically about the information that we've got here, we've got a class of boys and girls. It says the total for the class is 1,800, the total for the girls is 1,080. So logically we can work out now the total for the boys, we can subtract those away from each other. So 1,800, take away 1,080, and let's write that down. There we go, take away 1,080, leaves us with 720. There we go, and that's the total for the boys. Let's label that up, total for boys. And now we can go about answering the question, because now we know the total for the boys, we can actually think about working out their mean, and that's what the question wanted. It said work out the mean for the boys. So we've got the total for the boys is 720, and in total up here, we were given in the question, let's highlight in the same colour, there are 10 boys. So to work out the mean, just like normal, we would just finish this off by saying the total for the boys is 720. I'm going to divide that by how many boys there are, which is 10, and that gives us a mean of 72. There we go, and there's our final answer. I'm just thinking about what we did there, just working backwards through the question, multiplying the means by the amount to get the totals, and then using a bit of logic there to find out therefore what the total for the boys must have been, and then just working out the mean as normal.
Okay, well done for making it to the end of the video. That was AQA Foundation Paper 2. Don't forget to subscribe to the channel so that you'll get notified when Paper 3 comes out, and all of my upcoming revision videos for these 2022 GCSEs. Hopefully you found that useful and helpful. If you did, don't forget to like, don't forget to comment, don't forget to subscribe, and I'll see you for the next one.